Hi guys, welcome back to Physics 150. This video is the solution for the tutorial 4 here. Okay, so tutorial 4. Question 1. Okay, tutorial 4, question 1 will be this one. Define Ohm's Law A. So look at Ohm's Law. Ohm's Law states that the current that flow through a conductor, okay, is directly proportional to the potential difference, okay, across the conductor, okay, and with assumption that, okay, with assumption that the conductor, okay, is at constant temperature. It does not heat up. All right. So mathematically, we have this one directly proportional to voltage, and we form equation. We have this one, but normally we write it the other way around. So this one become 1 over Ki. So this one is K prime. Your K prime is actually discovered to be R. Okay, this is R. So V equal to IR. That is our Ohm's law equation. Okay, so that's it for A. Now come to B. Our B says that determine the value of resistance R, the big R, any one of them, if the equivalent resistance in figure 1 is 100. The total resistance here is 100. So we're going to redraw that diagram and simplify them. First, we're going to simplify these three, 1, 2, 3, so that our diagram will be there in series, right? So this is our first diagram. Okay. Here, this is A, B, so we have 1, 2, 3, okay, 1, 2, 3, 1, 2, 3, and then these three will be combined. So since they're in series, so this one is 3R, and this one is R, the rest are all R, all right? And then we combine these two, see, they are in parallel, right? So how do we solve that? So again, using the same method. Sometimes direct diagram help us a lot. Yeah, without diagram, you'll be lost actually in the transformation of the diagram. So this is R. So now this part here, I will call the R prime. Okay, R prime. So I have to calculate R prime based on the formula of parallel connection. So that is the way we solve it. 1 over 3R or 1 over R prime. This one will become 3R here. Okay, 3R. This one multiplied by 3, so have 4. So your R prime is actually 3 over 4R. Alright? So that is our R prime value, 3 over 4R. Okay? And then, again, if you look at the diagram, repeat itself again. Same like the one before, yeah? Same like the one before. So now we're going to combine these three. This R, and this R prime. So they are in series. Again, we have a simpler way to solve them. A, B, this is R. So now, this one, when they are combined, I'll call them R double prime. Okay, double prime. So your R double prime is equal to 2R here, because in series, right? Plus your R prime, and your R prime is 3 over 4R. So what do you have? 2 times 4, add plus 3 is 11. So 11 over 4R. So that is our R prime. Yeah, that one. It does not involve number, yeah, a lot of ratio. So make sure that you are good in your mathematics here. These are fraction, actually, fraction. And after that, we repeat the same thing, parallel again. So we redraw the diagram. This is R, this is A and B. Now we combine them, so I call this one R triple prime. Okay, R prime, right? Okay, R triple prime in parallel, right? Again, using this method is equal to 1 over R, this one, plus 1 over this one. So it will become 4 over 11R here. Upside down, okay, upside down. So now 1 over R prime 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 is equal to 11R here, okay. So multiply, get 11R. So this one is 11 plus 4, you got 15. So your R triple prime is equal to 11 over 15R. Alright. And finally, we already come to the last part here. This is A, and this is the R equivalent, okay. And our R equivalent is in series, okay. So we combine them. You have 2R plus your R prime prime prime. So that is 2R plus 11 over 15R. So got 30 plus 11, 41 over 15R. So that is your R equivalent. But you are given, okay, your R equivalent is equal to 100 ohms. So that means your 41 over 15R is equal to 100 ohms. So let's check whether we get the answer as the one given or not. 100 times 15 divided by 41, you got 36.6. Okay, 36.6 ohm. Alright, got it. We hit the jackpot. Alright, correct. Next one, C. Okay, C. Okay, C. What is the total current in figure 1 if a 50 volt battery is connected between point A and B? Well, we want to calculate total current. We simply assume that, see, you have a battery here, you connect to A and B like that directly, okay. And this is our R equivalent. You already got the value of 36.6 ohm, and the V here is 50 volt, okay, 50 volt. So from Ohm's law, B equal to IR. This one is 50 and this one is 36.6. So we have 50 divided by 36.6. So answer is 1.37. Okay, the current, the total current passed through main circuit, yeah, pass through this one. The main circuit is 1.37. Sorry, 1.37. Look at this one. What is the total current in figure 1 if a 50 volt battery is connected between point A and B? So you have this one, 36.6, right? 36.6 ohm, right? And then voltage 15. So directly we have divide. Okay, that is 50. Let's check again. 50 volt divided by 36.6 is equal to 1.37. Okay, 1.37 ampere. So the answer is wrong. Okay, so the answer is wrong. Rubbish. Okay, rubbish. So that is our answer for C. Okay, next question 2. Okay, question 2. Well, question 2, that is easy. We can do it here. Question 2, determine the equivalent resistance of the circuit shown. Okay, our circuit is something that looks like this. 3 resistor. I hate when you use that symbol, right, for resistor. Remember, I told you already, don't use that symbol of resistor. Okay, so I call this one R1, R2, and this is R3, and this is V equal to 12 volt. R1 is 820, R2 is 680, R3 is 960. Okay, so we need to calculate, we need to redraw the diagram. Okay, redraw the diagram. Now, how does it look like? Our diagram is going to look like this now. Going to put everything like that. So battery here, again battery, we leave it there, no changes. Now, this thing will be bent, okay, so that it looks like this now. So this one is R1, this is R2, and your R3 is alone, lonely, okay, alone. So that is what we have. Okay, R1, R2, R3. So now it's much easier to see, right? You want to calculate the total equivalent. First, you must solve this part first, okay? Part 1, and after that, after solving this part, then you solve the total part number 2, right? I hope you can see the green color there. Okay, come back. We solve part 1 here. Okay, so our diagram is going to look like this now. Okay, we use arrow to follow the diagram here. These two, that will be combined. R3, we leave it first. Okay, we don't cut out R3. So R3 is here. Now this one is a new resistor, so we call R12. Okay, R12. Now compared to this one, we don't label it 1, 2, 3, so we use R prime, 1 prime, double prime, triple prime, and so on. So like that is easier. You use follow them. So you combine R1 and R2. So what you get is R12. Okay, R12. So this our R12 is parallel, so we have to calculate them parallel. Yeah. So we calculate 1 over R12 is equal to 1 over R1 plus 1 over R2, which is 1 over 820 plus 1 over 680. Okay, we get our answer directly. See whether we can get or not. 820 plus 680. Okay, and oh, okay, sorry, try again. 820 plus 680. Okay, we got this, and then this one equal to 372 ohm. Okay, so our R12 is 372 ohm, number 1. And finally, we're going to combine them all together. So now it only has one resistor with a voltage 12V connected. So this one is the R equivalent. Don't use R123 because this is the final one. The final one you use R equivalent. If let's say I got 7 resistor, you still want to trace a number, that will be R1, 2, 3, 4, 7. It's not very smart. Okay, so R equivalent here, because they are in series, I think we can calculate straight away. R3 is 960, so we have this. Okay, so R3 is 960, so 960 plus this one 372, we got 1332 ohm. All right, so that is our final equivalent resistance. That is A. Okay, that is our A. Yeah. All right, B. B, the voltage across each resistor. All right, so we are going to use this diagram here. Okay, we use this diagram to help us. Okay, from here, the voltage, okay, V is 12 volt. This is R12, this is R3. You need to find out what is the voltage for each of the resistor here. So this voltage here I will call V3, and this one is V12. Okay, so before that, before you can calculate the voltage, the first thing we need is we have to find out the current here. Okay, find out the current so they can use Ohm's Law. Okay, we can use Ohm's Law. So current here, okay, I use blue color to calculate this part here. According to Ohm's Law, V equal to IR. Your R here is equivalent. This one is 12, and the current is this one, I, and multiply by 1332. Okay, so we calculate the I to be 12 divided by 1332. We got 9.01 milliampere. Okay, 9.01 milliampere. All right, so that is referring to this diagram. Okay, so now we already have the current I here passing through each of them, so you can calculate V12 is equal to I multiplied by R12. So we have 9.01 milliampere multiplied by R12. What is R12? R12 is 372. So let's find out. This one here multiplied by 372. Okay, we got 3.35 volt. And then V3 is equal to IR3. So we get 9.01 milliampere multiplied by, that one is 960. Okay, again, we use that one to multiply 960. Okay, we got this 8.65 volt. Okay, 8.65 volt. All right. So now we know the voltage. Okay, we simplify here. The V1. Okay, you see, R1, R2 are parallel. We combine them, become R12. So that means if they are parallel, they are supposed to have the same voltage. So the voltage across V1 is equal to voltage across V2 is equal to V12, okay? And it is equal to 3.35 volt, okay? And then V3, of course, is direct calculation at 0.65 volt, right? Now, if you want to try something here, you can actually sum up these two, see what happens. 3.35 plus 8.65, you're supposed to get 12 volt, okay? If you round up to the correct number, all right? So that is our question number 2. Okay, question number 2. All right. Okay, question 2. This is our page 1. So now we go to the next question. Okay. Okay. Next question. Okay. Question 3. All right. Question 3. Refer to figure 3. What is the net resistance or the resultant resistance of the circuit connected to the battery here? So we just need to find out, simplify the diagram. Okay, here. So this is question 3. If you look carefully, the diagram is given like this. Okay, I change the resistance symbol to this one, yeah. Here got one, and here got one, and this one to the battery. Okay, so another one here across diagonally. They are all R. Okay, R. Alright, but you are given R is equal to 1. Well, that will be easy. So first, we remember that we have to actually simplify the diagram one step at a time. So which part we can combine first? We can actually do this part first. You combine these two first. They are in series, right? So the rest we don't touch. Okay, the rest we don't cut out. So we leave the rest like that. So that you know how the tracing happen, yeah. And here, this is the battery with one resistor R here. So this is what we have. We combine them. So now we have something that looks like this. So I call this one R prime. But R prime is easy because they're in series. You see that? They're in series. So this one is equal to 2R. Okay, 2R. Alright. So that means we solve this part here. Number 1, and then after that we're going to solve these two. That is step number 2 now. So when you combine these two, it will leave you with only one resistor here diagonally. So this one still no changes. Okay. Alright, so that is our voltage R. Now this one I will call it R prime prime. Okay, R prime prime. So how do you get the R prime prime? Because they are in parallel, right? So 1 over R prime prime is equal to 1 over 2R plus 1 over R. So this is what you get. 2R here, and up here is 3 prime prime. Okay. So your R prime prime is equal to 2 over 3R. Okay, 2 over 3R. Okay. Now, where do we combine next? We are going to combine this one and this one here. That is our step 3. So now our diagram is going to be here. Okay, so the diagram here now, you have this horizontal one, this one, and the battery here. This is R, this is R. So now you have that two already combined. I will call this one R prime prime prime. Okay, they're in series, so it's very easy. R prime 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 is equal to R prime prime plus R, and your R prime prime is 2 over 3R plus R. So we're going to end up having a value of 5 over 3R, right? So that is our resistor for R triple prime. Okay, and then you have to combine these two again. So that is now your step 4, and we combine that. We get something that is only one resistor. Okay, This is R. So now I call this one R prime 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 4 times already. So now combine them using this 1 over R prime 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 equal to 1 over R prime 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 plus 1 over R. Okay, and this one is 1 over, this is 5 over 3R, and this 1 over R, this is 4 times prime. Okay, so simplify that is equal to 3 over 5R plus 1 over R, and this one is going to become, this 5R here, sorry, 5R. So here 5R multiplied by 5 sum up become 8. So your R 4 times prime is equal to 5 over 8R. Okay, 5 over 8R. This one here is 5 over 8R. Here. Alright. Now, what's next? Well, they are in series. Just combine them. So now you have only one single resistor. And now we don't use prime anymore. Why? Because it is the last one we use equivalent. So since it is series, our equivalent resistance can be summed up directly. 5 over 8R plus R. Okay, so it's going to become 13 over 8R. Okay, so 13 over 8R, but we know that R is equal to 1 ohm, so our R equivalent is equal to 13.8 ohms. Okay, so is 13.8 ohms equal to 1.6? Well, just divide, then you know. 13 divided by 8, yes, 1.63. Okay, 1.63. Okay, done. Not that difficult, right? But when you are sitting alone, doing alone, thinking of the exam this coming Saturday, I think you feel like it's quite difficult actually. Okay, next. Question 4. Okay, question 4A. What is the equivalent resistance of the circuit shown? Here you have to combine all of them. So this diagram is actually quite the same like this one. So we draw them in a proper manner. Okay, that one is like to make your life difficult only. Okay, we have one resistor here, and then here you actually have something that looks like this. Okay, and then in between you have one resistor here, like that. Okay, this battery here is 6 volt. 6 volt. Alright, so I think I will call this one R1, this is R2, R3 and R4. So my R1 is 12 ohm, R2, R3 and R4. R2 is 25 ohms, R3 is 18 ohm, and the last one is 4.5 ohms, so that you can trace when I change them. Okay, so what can we do first? Rearrange the diagram again. Okay, rearrange the diagram again. So this one is not that easy. Okay, not that easy. First, what can we do here? You look at this part here. This is a difficult part. Okay, this is a difficult part. But remember one thing: copper wire, you can bend them, right? You can bend copper wire, so there's no worry about that. So this is what we can do. Okay, this is what we can do. We combine these two, putting it here. So now we have a battery. Okay, and this one we bend it up. You see, this one is one resistor that looks like this. So this is my R3, and I'm gonna bend this one up. Okay, bend this one up. So what happened here is, when I bend it up, my R4 will be here now. This is my R4. See or not? This is my R4 now. I bend it up. And these two, I combine them. Okay, I combine these two, so now this is what happened. Yeah. Connected. See or not? This connected to R2, this one connected to both of them, R1, R2. Now it's simpler to solve. Okay. Now, you always have to have the ability to transform the difficult loop of the diagram or the circuit and then into something that is parallel to each other, either vertical or horizontal. Okay, because when you are given a diagram like that, your brain cannot process those non-organized structure. Okay, it's easier for us to solve problem when the diagram is more organized. Yeah. Okay, next. Now, which part we solve first? These two. We solve that two first. Okay, so that two, if we combine, we want to get something that looks like this now. Okay, so now this one R12, this is still R4, and we still connect to the battery here, and we have R3 here. Okay, R3, and this is the 6 volt. Okay, so we calculate our R12 here. Okay, here. So 1 over R12 is 1 over R1 plus 1 over R2. And what is the value? R1 is 12, R2 is 25. Okay, 25. So we need a calculator here. Plus 25. Okay, this one over. So we have 8.11 ohm. That is your R12 now. R12. And then what? Combine these two. Then we combine these two. So finally our diagram is going to be simpler like this now. Just now from here, go to here, from here, go to here, and now from here, go to here. Okay, we combine. So now you have smaller diagram. Okay, the V, this one I will call R124, and this is R3. R124, okay, is series, so you can sum them up. Okay, sum them up straight. So we already have 8.11, okay, plus your R4. What is the R4? R4 is 4.5 plus 4.5. So you get 12.61. Okay, 12.61 ohms. Okay, 12.61 ohm. And after that, we want to even simplify them and combine them into one single resistor only. V equal to 6 volt, and this is R equivalent. Yeah? So R equivalent is parallel. So we use the parallel method. That is 1 over R124 plus 1 over R3. So what do we get here? This is 1 over 12.61 plus R3 is 18. Okay, 18. So 1 over 18. Okay, so our equivalent value, see what do we get? 12.61 plus 18, this one, and our answer, this one. So we got 7.42 ohm. Alright, 7.42 ohm. Okay, for all this diagram here, you get that tiny answer. Okay, next one, B. What is the current in the 18 ohms resistor? Okay, 18 ohm resistor is this one. Okay, this one. So see that we use this diagram, okay, rather than this one, because by using this one you cannot see what the detail is. So when you see this, R12 and R4 and R3 are actually parallel with the battery. So that means the R3 is actually independent from the rest. The current here is independent from the rest because R3 is energized by this one. So you can actually take out only R3, okay, with the battery alone. So your R3, which is equal to 18 ohm, current flow here and in. Okay, sorry, current here, not that one. Yeah, not that one. Okay, here, and this one is I call R3. This one I will call R total. Okay, and this one is I3, and this one here I will call R 124. Okay, 124, because it passed through R1, R2, and R4. Okay, so Ohm's law, V equal to IR, 6 volt. Current is I3, R is 18, so your I3 is equivalent to 6 divided by 18, so answer is 0.33 ampere. Okay, 0.33 ampere. Okay, so that's our tutorial 4. That's it. See you next time.